carbonyl functional group is a carbon double bonded to an oxygen. There are two types of carbonyl groups, aldehydes and ketones. Aldehydes are when the carbonyl group on the end of the molecule attached to an R group, which represents an alkyl chain. For example, ethanol is when there is two carbons and the carbonyl group bonded to the end, with the suffix -al showing an aldehyde. This molecule has three carbons, so the prefix is prop, and so the molecule is called propanol. Ketones are when the carbonyl group is in the middle of the compound attached to two R groups or alkyl chains. For example, propan-2-one is when the three carbons and the carbonyl group is in the middle on carbon 2, hence the 2. This compound has the carbonyl group on the second carbon as the end nearest the carbonyl group is where you begin counting from, and the methyl group on carbon 3 means the compound is called 3-methyl-butan-2-one. Aldehydes are made by oxidizing alcohols. For example, ethanol oxidizes to ethanal by the addition of acidified potassium dichromate, which is shown in a reaction as the O here. And the product also gives water, as the OH from the alcohol and the O from the acidified potassium dichromate go together to make water. Ketones are also oxidized in much the same way, and the OH from them also combines with an O to make water and a ketone. While aldehydes can be oxidized further to carboxylic acids, ketones can't, but we'll save that for later. Okay, aldehydes and ketones can be reduced back to alcohols using sodium borohydride, which provides H- or hydride ions. So, and the reaction is a nucleophilic addition mechanism. So, the H- provided from the sodium borohydride is attracted to the delta positive carbon in the aldehyde, so donates electrons there, forming a covalent bond. Since the H- was negative, it donates its electrons to the oxygen, making that negative, and so the oxygen attracts a H+ ion. The H+ ion then bonds to the oxygen, forming an alcohol. The same reaction happens with ketones and can be shown as a reaction rather than a mechanism. So here the sodium borohydride is just simply shown as H to simplify the equation, and the product again is an alcohol. Here pentan-3-al because the reactant was a ketone, so the product is a secondary alcohol.